Today is going to be a weird lesson. Some of you guys are going to find it super easy, like all of this makes super sense, you're like, this is taking forever to get through. And other people will be like, what's going on, right? This is different than other math lessons. There's lots of different ways to get to the answer, and how comfortable you're with the numbers and different approaches makes this lesson either super easy or super hard. So one of the things we talked about last day was how to compare numbers. So we're comparing fractions, and we talked about using mental strategies. Yes, check yourself out, come on. All right? And so some of the things we talked about is, hey, compare positive numbers versus negative numbers. You can tell what's bigger. And remember what bigger means is further right on the number line, right? We said, hey, if the two top numbers are the same, compare the two bottom numbers, right? And the bottom numbers tell you the size of the slice. The bigger the slice, the bigger the number. So 5 over 6 has cut into 6. This is bigger slices than cut into 7s, right? If you're comparing bottoms the same, you compare the tops. You compare whole versus partial. There was lots of different strategies we did. So there are 3 different strategies we learned to compare numbers with. And you just pick and choose whatever method you want to get to the answer. And that's what makes it hard. This is 3 different strategies, right? So today's assignment, right here, we have a question, all of them about comparing numbers. Here, we have a bunch of questions. You have to figure out which number is bigger, which one is smaller. You can use the mental strategies that we talked about last day, or the 2 other things we're going to talk about today, right? So the 2 other things we're going to talk about today, well, we're going to spend mostly time on one strategy here, is first one I'm going to mention is you could, probably the easiest approach, the least amount of effort, is just turn all your numbers into decimals. Like we did last day. Top divided by bottom, turn the numbers into decimal. It's easy to tell what's big, what's small. Right? I'm not going to do any of those examples very much today. Right? That is a strategy more for grade 6, grade 7, grade 8. Still a valid strategy, right? We're not discount it, but I want to teach you some other things as well. So you're welcome to turn things into decimals. Sometimes that's the fastest way to do things, right? But we're talking about other methods. The other method is this one. Hey, as if the bottoms are different, it's really easy to compare if the things are the same in the bottom. So if you make the bottoms the same, all you have to do is compare the tops, right? That is finding the common denominator. So you compare with common denominators, right? So like this example here, 7 over 6 versus 11 over 9, which one's the bigger one, right? Both bottoms are different, both tops are different, both of them are bigger than a whole. It's very hard to mentally know which one's the bigger one. Some of you guys might know, but in general, this is not an easy one to tell apart. However, if you make the bottoms both the same, it becomes much easier to tell, right? So that process of making the bottoms the same is called finding a common denominator. And remember, we tried to pick the smallest one possible. So when you're picking the smallest one possible, we use this phrase called LCM. That's going to show up more next year. I just want to mention it this year because that's what we're doing. LCM is lowest common multiple, right? So if you're not good at your multiplication, we use our multiplication chart, right? We look at all the multiplications of 6. We look at all the multiplications of 9. And you're trying to find the one that's in common. Does anybody know what it is?
3.
Oh. No, 18. All right? All right? I love the enthusiasm. All right? So, here, if you're not sure, here is 6, here is 9. These are all the multiplications of 6. These are all the multiplications of 9. You want to pick the smallest one, 18. But there are bigger ones that they share in common, 36, and a bunch more. You can pick a bigger one. That just becomes a common multiple, right? And we just want the lowest one. So that means for our 6th fraction, we want to multiply by 3. for our 9 fraction, we need to multiply by 2 to turn these numbers to 18, right? So we go to here, okay, we're going to turn both numbers to 18. So that means this one gets multiplied by 3. Remember, top and bottom. To keep them equivalent, the top and the bottom need to be multiplied by the same number. So, and the other one gets multiplied by 2 to turn to 18. So we have 21 over 18, and you have 22 over 18. Now, since the denominators are the same, it's much easier to compare. What's bigger, 21 or 22?
22.
22. So the right fraction is the bigger fraction. So if you put the inequality symbol in, it'd be like this. Like that, right? The right one's bigger. So this is one valid strategy. If none of the mental tricks work, right? You could turn both of these numbers to decimals, or you can make both of the numbers common denominators and just compare. Either way. So just filling in some blanks here. The lowest common multiple, which we already did, between 6 and 9 is the number 18, right? Then you compare the top numbers, the numerators. Okay, so now, moving on. We just practice this, right? We want to compare these two numbers. Which one's the bigger one? Which one's the smaller one, right? We have these two, right? What's our common denominator between 3 and 5?
15.
15, right? So that means we want to multiply this side by 5, top and bottom, to turn into 15. That means we want to multiply this side by 3, top and bottom, to turn into 15, right? So we write out our new fractions. So we have 5 times 2, which is 10, and 5 times 3, which is 15. The other one, 3 times 3 is 9, and 5 times 3 is 15. Now that they look like this, it's much easier to compare. What's the bigger fraction? The left one or the right one? Left. So we go 2 over thirds is bigger. That's it. Okay. So now, valid approach. But you can get multiple choice questions next year and stuff like that, where they're going to expect you to sort of know some decimal fractions. What are the decimal values of certain fractions? And this third one is one of the ones they expect you to know. If I give you the fraction 1 over 3, does anybody know what the decimal value for that is? George?
0.3?
Yeah, 0.3, and that 3 just keeps on continuing. 0.33333, and you put a line, just means that 3 keeps on going in front. That's something that you should have memorized, right? It's going to come in handy, right? I'm not going to force you to memorize it, but it's something that should come in handy for a future on. Now, if you memorize that, then you know all your third fractions. 2/3 would be double that amount, right? 2/3 would be 0.666. If I wrote this as a decimal, right? So your third fractions, you should know. You should also know your fifths. What is 1/5 as a decimal? You want to take a guess? No, that 0.5 would be a half. That's not quite right. George?
0.2?
2. 1/5 is a 20th. Right? So this is 0.2. Right? So that means if you know your 1/5, you can figure out your your fifth calculations. 3/5 would be triple this amount. Right? It would be 0.6. Right? Now, if you did it as decimals, you could easily tell, hey, this decimal is bigger than that decimal. But you need to know those numbers. So there's some common ones, a third, a fifth. You need to know there's a couple more. We'll talk about one more in the next example after we make common denominators. So the next one, we have 8 and 4. What is our common denominator between 8 and 4?
16.
16. But there's something smaller. We can do 16, it will work.
8.
8. Right? So, times this one by 2 to turn it to 8. Right? And the other one, you don't have to change. But some people like to write down times ones, so you can write down your times ones. or just leave it blank, that's fine, right? So you have 12 over 8 and 4 over 8 as our two fractions. Which one's bigger? 12 over 8. Now, you didn't even need to do this, right? You could have done our mental strategies from last day, right? This one, the left one, is bigger than a whole. So we knew this one's less than a whole. So we knew right off the bat that this would be the bigger one, right? So this is where this lesson becomes tricky. There's so many different approaches. You can do this. You can use your mental strategy. You can turn both of these numbers into decimals and go that way, right? Whatever you want, right? Because I'm not telling you you have to do it this way. Pick one of the three things, right? So another fraction you should know is your 4s. So if you have 1 over 4, what would that be as a decimal? George?
0.25.
Yeah, 1 over 4 is a quarter. That's another one you should know. A quarter. Right? That means you can do all your quarter calculations. 2 over 4 would be double that, 0.5. 3 over 4 would be triple that, 0.75. Alright? So there's some common ones you should know. And they just make life a little bit easier when you're doing these kind of math questions. Alright? Alright. Okay, so now, to make things harder, we have these 4 fractions. We want to arrange them from least to greatest. That means smallest to biggest. They all have different denominators, all different numerators, so we need to make all 4 of them the same. So this becomes tricky. Peyton, you know it already?
Is it 18?
It is 18. And we'll talk about it, right? So we have 3, 9, 6, and 2. So if you're stuck, right, you go to your multiplication chart. Now let's go grab this one. Here, fresh one. We have 3, 2, 6, and 9 as our numbers. You want to look across all of these, and so now you look across 4 rows and you want to find something that's in common. To make life a little bit easier, when you have to look at more than 2 things, what you want to do is check if any of your smaller numbers is a multiplication of a bigger number. Like 2 and 3 can fit inside a 6. So that means that anything that works for 6 must also work for 2 and 3. Maybe it's 2 times 3 is 6. 3 times 2 is 6. They're inside of 6. So our last question, we did 6 and 9. We came up with a common denominator of 18, right? And if you look at 2 and 3, they both have 18 in it. So you didn't even have to look across 4 things. But if you don't see that, you can just look across all 4 things and find the common denominator. So we look at this. The 2 fraction, we're going to have to multiply by 9. The 3 fraction, we're going to have to multiply by 6. The 6 fraction, we're going to have to multiply by 3. 9 fraction, we're going to have to multiply by 2. In order to make all of them 18s. Right? So go like this. Go here. We're going to make all 18s. Right? And so that means the 3 fraction, we need to multiply by 6. Top and bottom. Right? So we write out a new fraction. 1 times 6 is 6. 3 times 6 is 18. Then we worry about the negative signs. And one of those tips we gave last day, if you have multiple negative signs, we do cleanup. Right? So we either want our answer to be positive or have 1 negative sign. Right? You don't need to have more than 1 negative sign on a number. If you have 2 negative signs, you combine them together. Does it make 1 negative sign or does it make a positive sign? Positive. Remember, 2 negatives make a positive. That's our multiplication rule. So these disappear. So we can just go 6 over 18 as a positive number. Right? Next one. We want to turn 9 into 18. So you have to times that by 2. 9 times 2 is 18. So the top gets multiplied by 2. This one only has 1 negative sign. So negative 8 over 18. That's fine. Right? To turn 6 into 18, we have to times it by 3. So the top gets times by 3. Right? And you got 15 over 18. 5 times 3 is 15. 6 times 3 is 18. Now we have the negative sign. So remember last day I said the negative can be anywhere on the fraction? They have the negative on the bottom. That makes hard to compare. We want the bottoms all to be the same, typically positive numbers. So we're going to take that negative from the bottom and just move it up to the top. Makes it easier to compare. So all the bottoms are going to be perfectly 18. And finally, the last one. We have 2 times 9 is 18. So the top and bottom gets multiplied by 9. So we end up with 9 over 18. Right? So now we have all of our numbers written as out of 18. So we rank them from smallest to biggest. Right? Smallest is most negative. So which one's the most negative?
Negative 15.
Negative 15 over 18. So now, for your assignment, I'll give you full credit if you write down negative 15 over 18. So next year, your teacher won't. If the teacher asks you questions like this, they want you to rank the numbers like this. This is the strategy you to figure out, but you should rank it with the original number. So right now, I'm going to rank it with the original number. So that means, hey, this number is this, so that's our smallest one. So I'm going to start off with that on the far left. This is just your strategy that you use to figure it out, right? So that one we used up. All right, what's the next biggest number?
Negative 8 over 18.
Negative 8 over 18. I'm going to write down the original number, which is negative 4 over 9. Right? So that one's gone. And then you have 2 left.
6 over
6 over 18. So I'll write down the original number. It looks like that. And then we have the last one, 1/2. That's it. Okay. So now, you had a question like this on your test for exponents. Hey, I said, hey, write these exponents from smallest to biggest, or biggest to smallest. I can't remember how it went. All right? That's a very common question. You're working with numbers. You're ranking them small to big or big to small. Right? It's going to happen with exponents. It's going to happen with fractions. It's going to happen with all different kind of numbers you're working with. But sometimes we use other words. There's another word to say least to greatest. It starts with the letter A. Does anybody know what that means? If I say this math word from least to greatest, it's actually an English word. Does anybody know what that word is?
greatest.
From small to big, all right? Another way of saying that, right, is the word ascending. So you may get a question saying, hey, write this in ascending order. It means small to big. Or I may ask you to do the exact opposite. I may say greatest to least, or the opposite word for ascending. Descending. Right? So all these things are asking you the same things. You just need to get used to the vocabulary. Big to small. Like, if you get confused, I like thinking descending, like your plane descends. So if I'm flying, it descends to the land. Or you're descending down the mountain when you're hiking, right? Right, so you figure out a way to memorize these things. That's not too bad. All right, on to the backside. Okay, so now we put all these different strategies together and we use whatever we can to answer the question. Here we have 4 fractions. All these 4 fractions, they are on this number line. They're either the letter C, B, A, or D. Right? We have to match the letter to the fraction. Hopefully using a combination of all of our strategies. And I'm going to teach you another strategy right now. Right? These are the typical multiple choice questions, no calculator, ask kind of things. When you're doing the number line kind of things, it's usually easiest from a list to pick out the biggest number and the smallest number. So you have 4 numbers here. These fractions. The biggest one is D, the smallest one is C. Out of these 4, which one's the smallest?
C.
C is the smallest, but which one of these fractions is C? Which one, all right? Let's talk about this. I see blank. George?
-4.
George thinks it's this one. At least you're on the right track, right? I think that you're off a little bit. So 0 is right here. So both of these are negative numbers. The smallest one has to be a negative number. So that means it's one of these 2. Right? And C is the most negative. So little bit more than -1. A little bit more than a whole. So it would have to be this one right here, because that's more than 1, more than a whole, right? So this would have to be C. Okay? Then we look at the biggest one. The biggest one is going to be a positive number, right? And this was this chapter hard. It's like, okay, what are you doing here? There's so many different things you can do. Well, we have two positive numbers, 8/10 and a half. Which one's bigger? Sorry, Tucker?
8/10.
Yeah. Like if you don't see it, like half of 10 would be 5/10, right? So 8 is definitely bigger than halfway. So this is definitely the bigger positive number. All right. Okay, so now we eliminated half the numbers. We got 2 left. We have B and A left to figure out. Well, B is a negative number. What's the only other negative number left over? Is this one. So this one has to be B. A is your other positive number left over, so that one has to be A. So we just did all these questions without picking up a calculator, right? Right. So that's the kind of strategies you're gonna have to start doing, right? And I know you're not quite ready for it. Some of you guys aren't ready, but you get there. And we'll skip this. We sort of talked about this already. Okay, let's do another one. A little bit more complicated, right? Because this time we got 6 numbers, and some of them are fractions, some of them are decimals. Right? So we have a mixture of style of numbers. But we're gonna use the same strategy, right? Out of these 6, what's the biggest? And what's the smallest?
F.
F is the biggest. Biggest is a number a little bit more than 2. A positive number a little bit bigger than 2, according to the number line. So, what is our positive number a little bit more than 2?
2. Top right.
Top right, 2 and 1/5. So we only have 2 positive numbers. We have this one here and this one here, right? This means, remember when we convert these things to decimals? 2 and a bit. 2, a little bit more than that. So this is our most positive. All right. What is our most negative? A little bit more than -2. Right? Which one is that?
Middle bottom.
Middle bottom, -2.1. Right? There we go. That's it. Done. All right? So now, this EAC, that's going to be the hardest to do. We have 3 numbers cramped into a tiny space. So that means they're very similar in value. So let's do a process of elimination. We have 4 numbers left. Let's get rid of D first.
Top left.
Now D is our positive number, which is our top left, 7/4, right? A number a little bit less than 2. And I'm hoping you can look at this and you can sort of know this is a little bit less than 2, because 8/4 would be exactly 2, and 7 is a little bit less than 8. Right? So this one must be D. Okay, so now we have E, A, C left. They're all very close, all negative numbers, right? This is where we use the same approach again. We have 3 numbers left. What's the most negative? What's the most positive? And by the way, what's the decimal version of this? It might come in handy. What's 1/3? We talked about it on the first page. 0.33333, right? Negative 0.3333 this time, right? So we have these 3 numbers left, right? Which one is the most negative?
Middle top.
Middle top is not the most negative.
The last one.
Which one's the last one?
Like far right.
Far right one, right? Negative 0.49 is more this way than that one. All right, so this one would have to be E. Then we have these 2 left, right? So one is closer to 0, the other one is more negative. So let's talk about closer to 0. Which one of these 2 left over
Middle.
is the middle one is closer to 0? right? This one's more negative.
This one has all the two.
Yeah, because it has all those threes, pushing it further away. So that's, this makes this one C, and that makes this one A. Right? And that's sort of what you want to do. And if you're really feeling overwhelmed, you can just turn every single one of these numbers to decimal and just place it that way. That is valid. You can do it. Right? But I want you to start using strategies. And when you get good at these strategies, you can do this question in seconds. All right? All right. Last question. All right. A combination of the previous two questions put together. We have these numbers, and we want to put them on the number line. All right? And since we have a mixture of fractions and decimals, we either have to make everything fractions so we can compare them, or we make everything decimals so we can compare them. Now turning decimals into fractions, that's kind of a pain. So it's probably just easier to go the other way. Let's turn these numbers into decimals. All right? 5/8. All right? Eighths. This is another one not used as often, but it's quite a common one. Does anybody know what 5/8 is a decimal? If your parents are into plumbing, they probably know this. This is a standard pipe size, 5/8. Does anybody know what that is a decimal? Right? So 5/8, right? Once you start getting older and you start fixing things around your house, right, is 0.625. So if you grab your calculator, you're not sure, you don't have to know it, but you have your calculator. So on my test, you'll be allowed to use your calculator. So you go 5 divided by 8, it gives 5 divided by 8, 0.625. Okay, how about 9/10? You have two 9/10s here. One's positive, one's negative. What's that as a decimal? Can you do that one in your head, George?
0.9.
Just 0.9. So this is 0.9, this is negative 0.9. Now, there is one question on your assignment today. All right? It's going to mention the word opposite. That's the only time it's going to show up in this chapter. But it shows up again later on this year. Right? The word opposite in math means opposite numbers. If I give you the number 5, the opposite of number 5 would be -5. If I give you the number -3, the opposite of -3, what would that be?
Positive.
+3. So now, on the assignment, it's going to ask you for opposite. Here, these two things are opposite of each other, right? -9/10 and 9/10. Right? Just something to throw out there. I know that it gets briefly mentioned in grade 8. It gets briefly mentioned now, and it'll get mentioned a little bit more later on. Okay, so we want to graph all of these. And it gets tight in here. Instead of graphing these numbers, let's just label them. Let's call this A, B, C, D, and E. That's what we'll put on the number line. So we're going to put all these 4 letters on the number line. Before we graph it, you got to know the spacing, right? Everything's not going up by ones. In this one, there are 1, 2, 3, 4, 5 lines before you hit 5. How big is each space? 0.2, right? And if you're not sure how to do that, what you do is you count the lines. There are 5 lines that make up 1. So you take 1 and you divide it by 5. These 5 lines make up 1. So you go 1 divided by 5. That's one of the fractions we talked about on the last page. 1 divided by 5 is 0.2. So each line is going up by 0.2. So you have, it's not written as a number, but this is 0.2. That means that's 0.4, that's 0.6, and that's 0.8. All right? So you just got to count by 0.2s. All right. Where would -2.2 be? It's near -2.
Yeah, one more space.
To the left or to the right?
To the left.
To the left. Right? Each line is 0.2. So you go one more line negative. So A is right there. All right. Let's do B, which is 0.625. All right. So Yeah, B right here, it's going to be in between 0.6 and in between 0.8. All right, somewhere in there. We have to do a rough guess. Is it closer to 0.6 or is it closer to 0.8? Yeah, so you need to be a little bit more accurate with your placement. So just a little bit right of it, not close to 0.8, but more on this side. There we go. B goes there, all right? C is negative 0.9, which means it's very darn close to negative 1. Do we go left? Do we go right of negative 1? To the right, yes. A whole space, half a space, many spaces? Half a space. Remember, this is 0.8. So 0.9 would be in between. So C is this. Now this is where the word opposite comes into play. Let's skip the next one. The other one's opposite. So that means it's a mirror image of this. This is on the negative side. The other one is going to be a mirror image of it on the positive side. So E mirrored on the other side. That's where E would be. A little bit less than 0.1. Okay. Finally, D. Okay. Negative 0.3. 0 is right here. We need to go to the negatives. Peyton, how far do we go?
Like a space and a half to the left.
Space and a half. That's good enough, right? That's negative 0.2. That's negative 0.4. Negative 0.3. Somewhere in between there. So space and a half. Excellent. All right. There we go. That's it. So now it says write these in ascending order, right? So we're going to go A is first, which is negative 2.2. Then the next one is going to be C, the next biggest one. That's negative 9 over 10. All right. Then we have D, which is negative 0.3 with a line. Then we have B, which is 5 over 8. Then we have E, which is 9 over 10. Small to big. Done. Okay? All right. So to compare numbers. One last thing. We're done our notes, but sometimes students struggle with comparing numbers. All right. If I said negative 1.6 versus negative 1.7, which one's the bigger number? 1.6. Negative 1. Remember, bigger means more positive. And usually with the negative ones, they get confused. So this is the more positive one. Okay. What if I gave you 1.5 and 1.5 with, 1.5 with a line over it? Yes. Remember, what does a line mean? It continues. It repeats. So if you're not sure, draw out a few extra decimal places, then compare. This is 1.55. This is actually 1.50. This is just zeros that go far. And this one is the bigger one. Okay. What if I had 1.5 versus 1.52? Let's go like this. This versus this. All right. George? 1.53. 1.53? So what does a double line mean? Both, whatever the lines of, that both continue. So here, let's draw it out. Right? We have 1.52, then the 5.2 continues. And continues and continues. We have 1.53, like this. And often, what students will go, hey, that other number is bigger. It's longer. So that makes it bigger. That's not true. You want to compare the decimal places. And George did it right. So in these numbers are the same. This is where our first difference happens. 3 is bigger than 2. So this is the bigger one. Right? And George did it right. But I just want to make sure that people sometimes just think the longer number is the bigger one. That is not true. You have to look at the digits. Right? That's it. Right? So you've got 40 minutes to